In this lesson, we're going to continue investigating proportions in chemical bonds. We're going to start with something you're all familiar with, table salt. Now, salt is the chemical sodium chloride, and sodium chloride is made of the two elements sodium and chlorine. Now, when Davies broke down salt into sodium and chlorine, he found a constant ratio of the mass of sodium to chlorine. For example, if you had a sample of 58 grams of sodium chloride, that would break down into 23 grams of sodium and 35 grams of chlorine. If your sample was 580 grams of sodium chloride, that breaks down into 230 grams of sodium and 350 grams of chlorine. If your sample's 348 grams of sodium chloride, that breaks down into 138 grams of sodium and 210 grams of chlorine. Now, the interesting thing happens when you look at the ratio between the masses of sodium and chlorine. If you divide the 23 grams of sodium by 35 grams of chlorine, you get a ratio of approximately 0.65. The same is true for 230 grams over 350 grams. That also equals 0.65. And then again, with 138 grams over 210 grams, you get a ratio of 0.65. So what Davies found from this is that in sodium chloride, there is a constant mass ratio of sodium to chlorine, and it equals approximately 0.65. Now, scientists found constant ratios like this in all sorts of substances they tested. Let's take a look at a few different salts made with chlorine. Here we have potassium chloride. If you were to measure the mass of potassium and the mass of chlorine in this salt, you would always find a constant ratio of about 39 grams of potassium to 35 grams of chlorine. Let's look at magnesium chloride. Here, you'll again find a constant ratio. This time, there will always be 24 grams of magnesium to approximately 70 grams of chlorine. One more example, hydrogen chloride. Here, you will have a mass ratio of 1 gram of hydrogen to 35 grams of chlorine. No matter how big your sample, this ratio will always be the same. Now, by the mid-1800s, scientists had discovered that chlorine was 35 times heavier than hydrogen. That means if you had the same number of hydrogen atoms on a scale as chlorine atoms, the chlorine would weigh 35 times as much as the hydrogen. Now, of course, there are way more atoms in a gram of hydrogen than shown here. In fact, I couldn't possibly show all the atoms in a gram of hydrogen. So we're going to use these rectangles to represent the atoms in a gram of hydrogen and in 35 grams of chlorine. Now we know that relative to hydrogen, chlorine is 35 times more massive. That's why we say that chlorine's relative atomic mass is 35. So again, 35 grams of chlorine is going to have the same number of atoms as 1 gram of hydrogen. And because hydrogen is the smallest atom, scientists decided to use the number of atoms in hydrogen as a benchmark. They gave that a name known as the mole. So, in a gram of hydrogen, there are a mole of atoms. And 35 grams of chlorine is also considered 1 mole. Now this is pretty cool because remember, in the molecule hydrogen chloride, there was always 1 gram of hydrogen for every 35 grams of chlorine. That means there's 1 mole of hydrogen for every 1 mole of chlorine. So the same number of hydrogen atoms as there are chlorine atoms. Therefore, they're always bonding in a 1-to-1 ratio. Let's take a look at one of our other salts. This was potassium chloride, and it had a ratio of 39 grams of potassium for every 35 grams of chlorine. Scientists know that potassium is 39 times heavier than hydrogen. That means it has a relative atomic mass of 39. And chlorine, as we know, is 35 times heavier than hydrogen. So there are the same number of atoms in 39 grams of potassium as there are in 35 grams of chlorine. So if we found this mass ratio in potassium chloride of 39 to 35, we have another 1-to-1 ratio of atoms. Finally, let's revisit sodium chloride. Now, sodium is 23 times heavier than hydrogen, so it has a relative atomic mass of 23 grams. Therefore, a 23-gram sample of sodium is 1 mole of sodium. And we recall that 35 grams of chlorine is also a mole of chlorine. Therefore, sodium and chlorine are combining in a 1-to-1 ratio in sodium chloride. In the second example, 230 grams of sodium is 10 times as much as 23. So there are 10 times as many moles. Similarly, in the 350 gram sample of chlorine, that's 10 times as large as the 35 gram sample, so that too is 10 moles. Again, we have a 1-to-1 ratio. And lastly, 138 grams is 6 times as much as 23, so this sample is 6 moles. And 210 grams is 6 times 35, so this is also 6 moles. Again, they're combining in a 1-to-1 ratio. This tells us that there is a constant unit ratio of sodium to chlorine, which equals 1. So the mass ratio is 0.65, and the atom-to-atom ratio is 1. In all of the salts we looked at here, the elements are combining in a 1-to-1 ratio. In the next lesson, we'll look at some compounds in which the fixed ratio between the elements is something other than 1.